Determination enthalpy change of neutralization by experiment. The materials and chemicals needed in this experiment are 1. Cup calorimeter. 2. 2 beakers. 3. Hydrochloric acid solution. 4. Thermometer. 5. 2 measuring cylinders. 6. Sodium hydroxide solution. Pour sodium hydroxide solution in beaker. The concentration of sodium hydroxide solution is equal 0.75 molarity. Pour hydrochloric acid solution in another beaker. The concentration of hydrochloric acid solution is equal 1 molarity. Measure initial temperature of hydrochloric acid solution. Read careful on thermometer. Initial temperature of hydrochloric acid solution is 27.3 degrees Celsius. Measure initial temperature of sodium hydroxide solution. Read careful on thermometer. Initial temperature of sodium hydroxide solution is 27.3 degrees Celsius. Both solutions acid and base are on the same temperature, 27.3 degrees Celsius. Before using calorimeter, I want to show you inside calorimeter. The cup calorimeter is made by 2 cups, the big cup and small cup. The inside of big cup is coated by thing which is bad conductor of heat, for example polyesters, cotton, and so on. The cover of cup calorimeter has 2 opens, one for thermometer and other for stirring rod. By using measuring cylinder, measure 50 ml of sodium hydroxide solution. We have exactly measured 50 ml of sodium hydroxide solution. Pour 50 ml of sodium hydroxide solution in cup calorimeter. By using second measuring cylinder, measure 50 ml of hydrochloric acid solution. We have exactly measured 50 ml of hydrochloric acid solution. After measuring, quickly pour 50 ml of hydrochloric acid solution in cup calorimeter, and close the cup calorimeter immediately so that no heat will be lost. Stir the solutions to allow the reaction occurs fast. The total volume of solution is 100 ml. The density of solution is around equal to density of water. Hence the density of solution is 1 gram per milliliter. By using density and volume you can deduce mass of solution. The mass of solution is equal to 100 grams. The reaction between acid and base is exothermic. The heat released is used to increase the temperature of solution. By reading careful on thermometer, the maximum temperature of solution is 32.5 degrees Celsius. The change in temperature is 5.2 degrees Celsius. Heat release during this experiment is calculated by the formula below. Heat, Q, is equal mass of solution multiply with specific heat capacity of solution multiply with change in temperature. The specific heat capacity of solution is around equal to specific heat capacity of water. The specific heat capacity of water is equal to 4.18 joule per Celsius gram. Mole of sodium hydroxide in 50 ml of solution is 0.0375 mole. Mole of hydrochloric acid in 50 ml of solution is 0.05 mole. According to balanced equation, 1 mole of hydrochloric acid react with 1 mole of sodium hydroxide. In this experiment, mole of sodium hydroxide isn't equal to mole of hydrochloric acid. Hydrochloric acid is excess reagent while sodium hydroxide is limiting reagent. For calculating enthalpy of neutralization, heat released by 1 mole, we have to use limiting reagent, sodium hydroxide. When 0.0375 mole of sodium hydroxide are neutralized completely, it releases 2173.6 joule. Hence when 1 mole of sodium hydroxide are neutralized completely, it releases 57962.6 joule. By converting joule into kilojoule, 1 mole of sodium hydroxide neutralized completely, it releases 57.9 kilojoule. The negative sign on energy indicate that the reaction is exothermic. Enthalpy change of neutralization is equal to negative 57.9 kilojoule per mole. Defining standard enthalpy change of neutralization. The standard enthalpy change of neutralization is the enthalpy change when solutions of an acid and an alkali react together under standard conditions to produce 1 mole of water. Meaning of standard conditions. Standard conditions are 298 Kelvin or 25 degrees Celsius. If reactants are gases, the pressure of gases must be 1 atmospheric pressure or 100 kilopascals. The solutions involved in reaction must have concentration of 1 molarity. In the description there are links for determining enthalpy change of combustion and enthalpy change of solution by experiment. Leave comments or questions below. Thank you for watching.